to fully realize the promise of autonomous vehicles and robots. While future-proofing the L2+ vehicles being designed today, you need centralized processing for the full range of raw environmental data, including radar. Central processing gives designers the ability to fuse raw radar and camera data, drastically improving environmental perception. That's precisely what you get with Ambarella's new centralized radar architecture, a breakthrough in central processing for raw AI-enhanced radar data. Ambarella's groundbreaking Oculi adaptive radar software uses AI algorithms to dynamically send out a phase-modulating waveform, while utilizing hardware and software sparsity. This drastically reduces the number of antennas required and the data generated, while increasing angular resolution by up to 100 times. Oculi technology makes it possible for the first time to centrally process raw imaging radar data, while enabling cost-effective data transport using currently available streaming options. That's because Oculi is the only radar technology that reduces the antenna count and raw data size, while also increasing the angular resolution. Likewise, Ambarella's 5nm CV3 AI Domain Controller SoC family, with its industry-leading AI performance per watt, is uniquely positioned to capitalize on our Oculi radar technology. CV3 marks the debut of our next-generation CV flow architecture, with a neural vector processor and a general vector processor, which were both designed by Ambarella from the ground up to include radar enhancements. These processors work in tandem to run the Oculi software at far higher performance than traditional edge-based radar processing, enabling centralized, single-chip processing for multi-sensor perception, including raw, high-resolution radar, camera, ultrasonic, and LiDAR, as well as deep, low-level fusion and AV path planning. Combining our patented Oculi algorithms with a CV3 SoC unlocks performance and cost improvements, such as an order-of-magnitude increase in radar resolution, point cloud density, range and sensitivity over systems that process radar data on edge modules, while enabling radar with significantly fewer antennas to achieve tens of thousands of points per frame with 0.5 degrees of angular resolution. Traditional radar needs at least an order of magnitude more antennas to achieve this resolution, which significantly increases the bandwidth needed to centralize data from each radar module. This is multiplied across the 6 modules required to cover the vehicle, making central processing impractical for other non-optimized architectures, which must process radar data at each edge module across thousands of antennas. Oculi technology provides an order of magnitude greater performance, achieving less than 0.5 degrees of angular resolution with significantly fewer antennas. This centralized architecture also uniquely enables dynamic processing allocation between radars and cameras for different driving scenarios and lighting conditions. These designs are streamlined by Ambarella's unified and flexible software development environment, which provides automotive and robotics designers with a future-proof platform for scaling performance from L2+ to L4 with fewer chips. Overall, Ambarella's new centralized architecture enables greater environmental perception and faster reaction times, which increases safety and makes it possible to fully realize the promise of autonomous vehicles and robots.